Hello everyone, in this video we are going to learn about the biostatistics portions. That's about data, types of data, classification based on sources of data, compilation, variable, nature, methods of data collection and classification, types of sampling methods, advantages and disadvantages of census and sampling method, class intervals, exclusive and inclusive method, frequency curve, types, skewness, kurtosis, ogive, and all these topics. So let's start. Before moving on to the topic, first let's learn what is biostatistics. Biostatistics is the application of statistical methods to analyze and interpret data related to living organisms and their interactions with the environment. It is a branch of statistics that deals with the design and analysis of experiments in biology, medicine, public health, and repeated and related fields. Biostatistics is used to help researchers and healthcare professionals understand data and make informed decisions based on the data. Biostatistics can be used to analyze data from clinical trials, observational studies, epidemiological studies, and other types of data. It can also be used to develop new statistical methods that are specifically designed to address the unique challenges of working with biological and medical data. Some common areas of biostatistics include designing and analyzing clinical trials to test new treatments or interventions, analyzing epidemiological data to understand the spread of diseases and risk factors, developing statistical models to understand the relationship between genetic and environmental factors in the development of diseases, analyzing healthcare data to identify patterns and trends in healthcare utilization and outcomes, designing and analyzing studies to evaluate the effectiveness of public health interventions. Biostatistics plays a critical role in advancing our understanding of human health and disease and is essential for the development of new treatments and interventions. Now let's learn about the major topic, types of data. In statistics, there are four main types of data: nominal, ordinal, interval, and ratio data. Each type of data has different properties and characteristics that affect how it can be analyzed and interpreted. Now, nominal data. Nominal data is categorical data that represents names or labels. Nominal data cannot be ordered or ranked, and there is no inherent mathematical relationship between categories. Examples of nominal data include gender, race, eye color, and political affiliation. So nominal data is a categorical data that represents names or labels. Nominal data cannot be ordered or ranked, and there is no inherent mathematical relationship between categories. Examples of nominal data include gender, race, eye color, and political affiliation. Next is the ordinal data. Ordinal data is also categorical data, but it can be ordered or ranked. The categories in ordinal data have a natural order or sequence, but the differences between the categories are not necessarily equal. Examples of ordinal data include education level like high school, college, graduate school, and socio-economic status like low, middle, high, and movie ratings: poor, fair, good, excellent. Interval data. Interval data is a numerical data that has a meaningful 0 point and equal intervals between values. Interval data does not have a true 0 point, meaning that a score of 0 does not indicate the absence of the variable being measured. Examples of interval data include temperature measured in Celsius or Fahrenheit, IQ scores, and dates on a calendar. Just remember IQ scores because it's easy that 0 IQ doesn't mean that the person doesn't have intelligence. Like, we don't have a true 0 point, but we have a meaningful 0 point. And that meaningful 0 point doesn't indicate the absence of a variable being measured. So that's about interval data. Next, ratio data. Ratio data is also numerical data but has a meaningful 0 point and an equal interval between values. But unlike interval data, ratio point does not have a true 0 point. But unlike interval data, ratio data has a true 0 point that indicate the absence of the variable being measured. Ratio data can be used to calculate ratios and proportions. Examples of ratio data include height, weight, age, and income. Understanding the type of data being analyzed is essential for choosing appropriate statistical tests and interpreting results accurately. Nominal and ordinal data are often analyzed using non-parametric tests, while interval and ratio data are analyzed using parametric tests. Additionally, different types of data may require different types of graphical displays, such as bar charts or nominal and ordinal data, and histograms or box plots for interval and ratio data. Next topic, classification of data in the basis of source of data, compilation, variable, nature. So first, classification of data. Data can be classified on various ways based on different criteria. In essay, we will discuss the classification of data based on the source of data, compilation, variable, and nature based on the source of data. Data can be classified based on the source from where it is obtained. There are two main sources of data, primary and secondary. Primary data is the data that is collected by the researcher from the original source for the first time. This data is raw and unprocessed and is collected through surveys, experiments, observations, and interviews. Next is the secondary data. Secondary data is the data that is collected by someone else for some other purpose and is later used by the researcher. This data can be obtained from books, journals, government reports, websites, and other sources. Now, let's classify data according to compilation. Data can be classified based on how it is compiled. There are two main types of data, individual and aggregate. Individual data refers to data that is collected for each individual in a population or sample. This type of data is also known as raw data or unit data. Next, aggregate data. Aggregate data refers to data that is obtained by combining individual data. This type of data is also known as summary data or group data. Next, based on variable. Data can be classified based on the type of variable being measured. There are two main types of variables, qualitative and quantitative. So, qualitative data refers to data that is non-numeric and describes characteristics or attributes of the subject being studied. Examples of qualitative data include gender, race, religion, and marital status. Then, quantitative data. Quantitative data refers to data that is numeric and measures quantities and amounts. Examples of quantitative data include height, weight, temperature, and time. Now let's classify data on the basis of nature. Data can be classified based on its nature. There are two main types of data, discrete and continuous. Discrete data refers to data that can only take one specific values and cannot be measured beyond those values. Examples of discrete data include the number of children in a family, the number of cars in a parking lot, and the number of students in a classroom. Continuous data refers to data that can take on any value within a range and can be measured to any degree of precision. Examples of continuous data include height, weight, and temperature. In conclusion, data can be classified based on various criteria such as source of data, primary and secondary, compilation, raw data, and another type of data like aggregate data, individual data and aggregate data. Then based on variable, we just classified it as qualitative and quantitative. Next, based on nature, discrete and continuous. So we just classified data based on criteria such as source of data, compilation, variable, and nature. Understanding classification of data is important for selecting appropriate methods of data analysis and interpretation. Next topic, methods of data collection and classification in detail. So data collection is a crucial step in any research process. It involves gathering information or data from various sources that are relevant to the research question or problem. The methods of data collection can vary depending on the nature of the research question, the type of data needed, and resources available. In this essay, we will discuss the methods of data collection and classification in detail. So, methods of data collection. Surveys involve collecting data from a sample of individuals or groups through questionnaires or interviews. Surveys can be conducted through various modes such as mail, telephone, online, or in person. The data collected through surveys can be either qualitative or quantitative. A company conducts a customer satisfaction survey to understand customer needs and improve their services. Observations involve collecting data by observing and recording the behavior or actions of individuals or groups in their natural setting. Observations can be either participant or non-participant, and the data collected can be either qualitative or quantitative. A researcher observes children playing in a park to study their behavior and social interactions. Next, experiments. Experiments involve collecting data by manipulating a variable and observing the effect on the outcome variable. Experiments can be conducted in a laboratory or in the field, and the data collected is typically quantitative. The data is quantitative. A researcher conducts an experiment to test the effectiveness of new drug on patients with specific medical condition. So, experimental data. Next, case studies. Case studies involve collecting data by studying a particular individual, group, or situation in depth. The data collected through case studies can be either qualitative or quantitative. A psychologist conducts a case study on a patient with a rare psychological disorder to understand the causes and symptoms of the disorder. Classification of data. Once data has been collected, it needs to be classified into different categories based on the type of data. The classification of data is important because it helps researchers to organize and analyze the data effectively. The following are the different types of data classification. Quantitative data. Quantitative data is numerical data that can be measured and analyzed statistically. This type of data can be further classified as discrete and continuous. The height and weight of students in a class are quantitative data. Next, qualitative data. Qualitative data is non-numerical data that describes a characteristic or attribute of a subject being studied. This type of data can be further classified as nominal and ordinal. A gender and occupation of employees in a company are qualitative data. Next, primary data. Primary data is data that is collected by the researcher for the first time, and it can further classified as raw or compiled data. A survey conducted by a company to understand customer needs is an example of primary data. Secondary data. Secondary data is data that has already been collected by someone else for another purpose, and it can be further classified as published or unpublished data. A researcher using data from a government report to conduct a study is an example of a secondary data. In conclusion, the methods of data collection and classification are essential in any research process. Researchers need to carefully choose the appropriate method to data collection and classify the data accurately to ensure effective analysis and interpretation. Next, types of sampling methods. Sampling is a process of selecting a subset of individuals or units from a larger population for the purpose of making inferences about the population as a whole. In research, sampling is crucial as it allows researchers to make inferences about a population without having to study every individual or unit within that population. In this essay, we will discuss the different types of sampling methods. Probability sampling. Probability sampling involves selecting individuals or units from a population randomly. This means that every individual or unit in the population has an equal chance of being selected for the sample. Probability sampling is considered the most reliable sampling method as it minimizes bias and provides a representative sample of the population. There are 4 types of probability sampling, like simple random sampling. In simple random sampling, individuals or units are selected randomly without any bias or preference. Next, a researcher selects 50 students from a college using a random number generator, so there won't be any bias related to this. Next, systematic sampling. In systematic sampling, individuals or units are selected at regular intervals from a list of sequence. A researcher selects every 10th student from a list of patients in a hospital. Then stratified sampling. In stratified sampling, individuals or units are selected from specific subgroups or strata within the population. The subgroups are determined based on characteristics such as age, gender, or ethnicity. A researcher selects a sample of 100 students from a college with 25 students selected from each year group. That is stratified sampling. Next, cluster sampling. In cluster sampling, individuals or units are selected from groups or clusters within the population. The clusters are determined based on geographic location or other similar characteristics. Example, a researcher selects a sample of 50 households from a town by randomly selecting streets and then households within those streets. That is cluster sampling. Next, non-probability sampling. Non-probability sampling involves selecting individuals or units from a population using non-random methods. This means that not all individuals or units in a population have the equal chance of being selected for the sample. Non-probability sampling is considered less reliable than probability sampling as it can result in biased samples. There are four types of non-probability sampling. Convenience sampling. The convenience sampling, individuals or units are selected based on their availability and accessibility. A researcher selects participants for study by approaching people on the street. That is convenience sampling. Next, quota sampling. In quota sampling, individuals or units are selected based on predetermined quotas for certain characteristics such as age or gender. That is quota sampling. This is a biased one. And the researcher selects 50 participants for a study, 25 males and 25 females. Next, purposive sampling. In purposive sampling, individuals or units are selected based on the specific criteria determined by the researcher. The researcher selects participants for a study based on their experience in a particular field. Next, snowball sampling. Snowball sampling, individuals or units are selected based on referrals from other participants. A researcher selects participants for the study by asking current participants to refer other potential participants. In conclusion, the choice of sampling method depends on the research question, the nature of the population, and available resources. Probability sampling is generally considered more reliable than non-probability sampling, but non-probability sampling can be useful at certain situations where probability sampling is not feasible. It is important for researchers to carefully consider their sampling methods to ensure that their sample is representative of the population and minimize bias. So, which were the major sampling methods that we just learned? Let's have a quick recap. Simple random sampling, systematic sampling, stratified sampling, cluster sampling, and then non-probability sampling, along with that convenience sampling, quota sampling, purposive sampling, and snowball sampling. Next, advantages and disadvantages of census and sampling method. In research, there are two primary methods of collecting data: census and sampling. We all know that. So, census involves collecting data from every individual or unit within a population, while sampling involves selecting a subset of individuals or units from a population for the purpose of making influences about the population as a whole. In this essay, we will discuss the advantages and disadvantages of census and sampling methods. First, learn about the advantages of census. Accurate representation of the population. A census provides a complete and accurate representation of the population, as every individual or unit is included in the data collection process. Detailed information. A census provides detailed information about the population, including demographic data, socio-economic data, and other available variables. Useful for small populations. The census is useful for small populations where it is feasible to collect data from every individual or unit. Disadvantages of census. Expensive. It's a very expensive process. Conducting a census can be expensive as it requires significant resources and time to collect data from every individual or unit within a population. Then it's time consuming. A census can be time consuming as it requires data to be collected from every individual or unit within a population. Next, privacy concerns are there. A census may raise privacy concerns as individuals may be uncomfortable with sharing personal information. So next, advantages of sampling. This is a cost-effective method. We don't have to spend too much energy, too much time, too much money into this. Cost-effective. Sampling is a cost-effective method of data collection as it requires fewer resources and less time than a census. Time efficient. Sampling is a time-efficient method of data collection as it only requires data to be collected from a subset of individuals or units within a population. Representative sampling. A sample can provide a representative sample of the population as long as the sampling method is appropriate and unbiased. Disadvantages of sampling. Risk of bias. Sampling can be subject to bias, particularly if the sampling method is not appropriate or if there is a sampling error. Less detailed information. Sampling provides less detailed information than a census, as only a subset of individuals or units are included in the data collection process. Limited use of small populations. Limited use for small populations. Sampling is less useful for small populations as the sample size may be too small to provide a representative sample. In conclusion, both census and sampling methods have advantages and disadvantages, and the choice of method based on the research question, the nature of the population, and the available resources. A census is generally more accurate and detailed, but it can be sensed. In conclusion, both census and sampling methods have advantages and disadvantages. And the choice of method depends on the research question, the nature of the population, and the available resources. A census is generally more accurate and detailed, but it can be expensive and time consuming. Sampling is most cost effective and time efficient, but it can be subjective to bias and provide less detailed information. Researchers should carefully consider their method of data collection to ensure that what is appropriate for their research question and population. Next topic. Class intervals, exclusive and inclusive method in detail with examples. In statistical analysis, class intervals are used to group data into intervals or ranges. These intervals are used in histograms, frequency tables, and other statistical analysis. There are two methods of defining class intervals, exclusive and inclusive. Exclusive class intervals. In the exclusive method, the upper limit of one interval is not included in the lower limit of the next interval. For example, if we have a set of data ranging from 0 to 100, we want to create 5 class intervals, we can use the following exclusive interval like this. In this method, the upper limit of each interval is not included in the lower limit of the next interval. This method is commonly used in statistics and preferred when the data is continuous. Advantages of exclusive class intervals. No overlap. Exclusive class interval do not overlap, which makes it easy to determine which interval a value falls into. Useful for continuous data. Exclusive data intervals are useful for continuous data as they allow for a clear and accurate presentation of the data. Disadvantages of exclusive class intervals. Limitations for discrete data. Exclusive data class intervals may not be suitable for discrete data as there may be gaps between intervals. Ambiguity. There can be ambiguity at the endpoints of the intervals as they are not clear whether value belongs to one interval or the next. Next is the inclusive class interval. In the inclusive method, the upper limit of one interval is included in the lower limit of the next interval. For example, if we have a set of data ranging from 0 to 100 and we want to create 5 class intervals, we can just do this like this. In this example, the upper limit of each interval is included in the lower limit of the next interval. This method is less commonly used in statistics, but it is preferred when dealing with discrete data. Advantages of inclusive class intervals suitable for discrete data. Inclusive data intervals are suitable for discrete data as they do not create gaps between intervals. No ambiguity. There is no ambiguity at the endpoints of the intervals as values that fall on the boundary are included in the interval. Disadvantages of inclusive class interval. Overlap. Inclusive class interval overlap, which can make it difficult to determine which interval a value belongs to. Unsuitable for continuous data. Inclusive data class intervals may not be suitable for continuous data as the overlap between intervals can distort the representation of the data. In conclusion, both exclusive and inclusive class interval methods are advantages and disadvantages, and the choice of a method depends on the nature of the data and analysis being performed. Exclusive class intervals are preferred for continuous data, while inclusive class intervals are suitable for discrete data. It is important to carefully consider the choice of class intervals and to ensure that it accurately represents the data and provides meaningful insights. Next topic is the frequency curve. In statistics, a frequency curve, also known as a density curve, is a graphical representation of a frequency distribution. It allows the distribution of data in a continuous or interval scale in a smooth curve. In this essay, we will discuss frequency curves in detail, including their types, characteristics, and how they are used in statistical analysis. Types of frequency curves. There are several types of frequency curves, including the normal curve, skewed curve, bimodal curve, and uniform curve. First, normal curve. The normal curve is a bell-shaped curve that is symmetrical around the mean. It represents a normal distribution of data where the majority of the data falls around the mean and the extreme values are rare. This type of curve is commonly used in statistics, especially in hypothesis testing. Next is the skewed curve. A skewed curve is a frequency data that is not symmetrical and the data is distributed more toward one end than the other. There are two types of skewed curve, left skewed and right skewed. Next, bimodal curve. Bimodal curve is a frequency curve that has two distinct peaks which indicate that there are two different groups of data in the distribution. Next, uniform curve. A uniform curve is a frequency curve where the data is evenly distributed across the entire range and there is no prominent peak or trough. So that's about uniform curve. Next, characteristics of frequency curve. Frequency curve have several important characteristics include shape. The shape of the frequency curve indicates the type of distribution of the data. Next, symmetry. The symmetry of the curve indicates the balance between the values on either side of the mean. Peak. The peak of the frequency curve indicates the value of range of values that occur most frequently in the distribution. Spread. The spread of the frequency curve indicates how widely dispersed the data is across the range. Uses of frequency curve. Frequency curves are used in statistical analysis to provide a visual representation of the distribution of data. They are used to determine the shape and characteristics of a distribution, identify outliers or extreme values in the distribution, compare different distributions and determine if they are similar or different, calculate the probability of specific values occurring in the distribution, compare different distributions and determine if they are similar or different. In conclusion, frequency curves are a powerful tool for understanding and analyzing data in statistics. They provide a visual representation of the distribution of data, and their shape, symmetry, peak, and spread can reveal important insights about the data. Understanding the characteristics of frequency curves is essential for conducting accurate statistical analysis and drawing meaningful conclusions. Next, frequency curve types: skewness, kurtosis, ogive in detail with examples. Frequency curve, also known as the density curve, is a graphical representation of the frequency distribution on a data set. It shows the distribution of data on a continuous or interval scale and the smooth curve. In this essay, we will discuss the detailed type of frequency curves: skewness, kurtosis, and ogive. Types of frequency curve. Normal curve. The normal curve is a bell-shaped curve that is symmetrical around the mean. It represents a normal distribution of data where the majority of the data falls around the mean and the extreme values are rare. This type of curve is commonly used in statistics, especially in hypothesis testing. Skewed curve. A skewed curve is a frequency curve that is not symmetrical and the data is distributed more toward one end than the other. There are two types of skewed curves, left skewed and right skewed. In a left skewed curve, the tail of the curve is on the left, and in the right skewed curve, the tail is on the right. Then bimodal curve. A bimodal curve is a frequency curve that has two distinct peaks, which indicate that there are two different groups of data in the distribution. Next, uniform curve. The uniform curve is a frequency curve where the data is evenly distributed across the entire range and there is no prominent peak or trough. So that is uniform curve. Next, skewness. Skewness is a measure of the asymmetry of a frequency distribution. A distribution can be positively skewed, negatively skewed, or symmetrical. A positively skewed distribution means that the tail of the distribution is longer on the right side and the mean is greater than the median. Mean is greater than the median. A negatively skewed distribution means that the tail of the distribution is longer on the left side and the mean is less than the median. Positively skewed means the mean is greater than the median. Kurtosis. Kurtosis is a measure of the peakedness of a frequency distribution. The distribution can be leptokurtic, mesokurtic, or platykurtic. Leptokurtic distributions are more peaked than the normal distribution. Mesokurtic distributions are similar to the normal distribution and platykurtic distributions are flatter than the normal distribution. Next, ogive. An ogive is a graph that shows the cumulative frequency distribution of a data set. It is used to visualize the cumulative frequency distribution and to determine the percentage of data that follows below a certain value. There are two types of ogives, like less than ogive, which shows the cumulative frequency of data that is less than or equal to a certain value, and the greater than ogive, which shows the cumulative frequency of data that is greater than or equal to a certain value. Suppose we have a data set of weights of a sample of individuals. The frequency distribution of this data set can be represented by a frequency curve The type of frequency curve will depend on distribution of the data. If the weights follow a normal distribution, the frequency curve will be bell-shaped, symmetrical, and the mean and median will be equal. If the weights are skewed, the frequency curve will have a longer tail on the right side and the mean will be greater than the median. If the weights are negatively skewed, the frequency curve will have a longer tail in the left side and the mean will be less than the median. If the weights are uniformly distributed, the frequency curve will be flat and data will be evenly distributed across the range. An OJ can be used to determine the percentage of individuals whose weight is below or above a certain value. In conclusion, frequency curves, skewness, kurtosis, and sheaves are important tools in statistical analysis. They provide a visual representation of the distribution of data and help to understand the characteristics of the dataset.